Hi, I'm Carl Franklin. In this episode of Blazor Train, we're going to turbocharge our remote access by using gRPC. gRPC is a standard that exists outside of .NET, outside of Microsoft. Fortunately, there are some great tools for using gRPC with .NET, and that, my friends, is like turning the old iron horse into a bullet train. Yes, there are limitations. Yes, you have to define your models using a completely different language, but how much performance can you gain from using gRPC over the standard API controller model? Well, the answer to that question is coming up right now, right here on Blazor Train. So we're going to compare how long it takes to access 5,000 records via your standard API controller to accessing those same records via gRPC. So I've created a hosted Blazor WebAssembly application called Blazor gRPC demo. And we're going to start with a model. In fact, I'm going to use the same person data that we used in a previous episode. So some of this might look familiar to you. To the shared project, I'm going to add person CS. So now I'm going to add a JSON file, this people.json file. I'm going to add that to my server project. It's a couple of megabytes, and it contains a whole bunch of records. In fact, 5,000 records. There they are right there. Okay, just a whole bunch of Latin names, Latin words that I've generated at a different place in time. So now in the server project, let's add a data folder and add a person's manager to it. So typically on the server side, a manager would access the data via entity framework or something like that. All we're doing here is loading in people.json, and we're deserializing that to our list of person objects called people. Okay, now let's add a controller. There's the controller, very simple. I'm making sure to inject a person's manager in there. And now I have a getAll, which just returns people, and getByPerson ID, which returns just a particular person by their ID. The IDs start at 1 and end at 5,000. Pretty simple for us. Next, we have to add the person's manager in startup so that we can inject it. There it is. Now let's go to the client project. Let's create a services folder and add an API service to it. Our API service injects the HTTP client, which, if you look in program, is set with the base address from the host environment, right? So if this is out on the internet, this is going to be a routable address, and if it's local, it's going to be localhost. So that's how we get around that. So here's the API service again. We've got our HTTP client. Now we've got a getAll that returns a list of person, and a getPersonById that returns a single person. So going back to program, we're going to now add that API service so that we can inject it into the index page. But of course, we've got to add some using statements to our imports first. There we go, one for services, one for the shared project. Now we can hijack that index page. So our index page injects the API service. We've got a button. When we click that, we're going to this API button clicked handler right there. And we also have this API result string, and we're defining people as a list of person. So the first thing we're doing is clearing whatever that result string is and invoking status change so it updates. We're also setting a timer. Start time now, right? It's right now. And then we're getting all the people back from the API service, and we're getting the elapsed time and simply setting the result to people count records returned via API in however many milliseconds that is. So let's see how long it takes using the standard API mechanism to access 5,000 records. There you go. About 2.2 seconds. Now, that's the first time. The second time, it's probably going to be under 2 seconds. Yeah, there you go. Just under 2 seconds. 1973 milliseconds. All right, that's a good baseline for us to see if we can beat it using gRPC. So the first step is we're going to get rid of our person class. Now, the person class is kind of critical because this is the model, right? But you see, when you use gRPC, you're going to recreate the models in another language, the Proto language. So it's actually going to look more like a message than a class, but you'll see what I'm saying. We're gonna use the same names and all of that stuff, so our existing code will be able to use it as well. You'll see what I mean. Let's exclude this. And we're going to add a Proto file to the shared project. Now, I'm going to come back to this Proto file in just a minute. But first, let's add the NuGet packages we need to all three of these projects, starting with the shared project. All right, so I've added Google Protobuf, gRPC Net Client, and gRPC Tools. And you can do this yourself through the UI. You don't have to copy and paste from here. Just manage NuGet packages and search for them. But the other thing you need is this little guy right here. Protobuf include people.proto. All right, that's going to be important for Visual Studio to know what to do with that file. All right, on to the server project. Here we're adding gRPC ASP.NET Core and gRPC ASP.NET Core Web. Very important. On to the client. To the client, we're adding gRPC Net Client Web. Now, since the client and server both have access to this shared project, one of the things I want you to notice when we click on this Proto is that there are some properties for this. The build action has got to be Protobuf compiler, and the gRPC subclasses is both client and server because they both have access to it. Otherwise, you'd have to copy the Proto file, from the server to the client project. This is just much better to have it in a shared project. All right, let's talk about this Proto file. As you might have guessed, message person is taking the place of our person class. Now, this is not C#, and the reason why it doesn't look more C#y is because Protobuf exists completely outside of the world of .NET. It's a standard, and as such, we have to follow its conventions. For example, int32 rather than int. All right, the property names, if you will, are camel cased, but they will turn into Pascal case once the C# class has been generated. Yes, a person.cs class will be generated from this. Also, these numbers right here are the number of the field, and they should just be in order because Protobuf does binary serialization. And so it needs to know what order these fields are in so it can properly serialize and deserialize them. Now at the top, you're going to see syntax equals Proto 3. And that is telling us we're using the Proto 3 version of Protobuf. The C# namespace, you should change to whatever the namespace is. Mine is Blazor gRPC demo.shared. I've got this get all people request message, think of it like a class, with nothing in it. And I have a people reply message, think of it like a class, with this repeated person, people. Okay, so people is the name of the property, if you will. And this repeated just means it's an array. It's an array of person. Now here's why I have nothing here, because when I call getAll, I have to pass something. I have to pass a message type. And you can't pass null, you can't do empty parens. It has to be something. So this is a way to get around that. And here's the service, right? Our people service. Here's a remote procedure call, getAll. It takes the getAll people request and returns a people reply, which contains a people property that's an array of person. Get it? So this Proto file is essentially defining the metadata, the structure, the classes, and the services and their inputs and outputs. Now it's up to you to implement a service. So let's do that now. Let's go to Data, and we're going to add a class called People Service. And by the way, you should probably build this, because that will generate all the classes and things. Now here's People Service, right? We have our persons manager again, and we have one method, getAll, but notice that it's an override. We're taking over the service, all right? The service is defined by that Proto and everything gets generated, but these are virtual methods. So notice that there's two parameters here. The first one is mandatory, a getAll people request, which is just nothing, right? And then there's always a context, a server call context passed. So the 3 lines of code are to create a new people reply, and then to the people property, we're adding a range from persons manager people. So we're adding those people right into it. Now, what's cool about this is the persons manager is now using the generated person class, not that person.cs class that we originally had. But since all the fields are identical, everything is going to work just fine. And now we're returning task.fromResult with that reply. And the reason we're doing this is because now it can be called synchronously or asynchronously from a client. Let's go to Program CS, because we have some stuff to do here if we're going to be able to access that client. There it is, and let's add our using statements here. So we're adding a singleton, and inside this we're creating a new HTTP client to access the service with the web handler, and we're getting the base URI from our navigation manager. Then we're creating a channel from that base URI with the channel options and the HTTP client. And finally, we're returning a new people.people client passing the channel. So this is all generated code. This all happened from gRPC.net. When we created that proto buff, it generated a person class, and it also generated this client class that does all of the communication using this HTTP information. So, you know, it's really cool because they handle all the heavy lifting for you, and then now you just have to call that client, that people client. A couple more things we need to do on the server side. In startup, we need to tell it to use gRPC, and also here under app use routing, we're going to tell it to use gRPC web. And we also need an endpoint for every one of the services that we're going to create. In this case, we just have people service, but we're going to map the gRPC service to that people service. All right, now we can replace what's in index with some updated code. Now we've got the people.people client injected, and I've got another button to test gRPC with a gRPC result string. And now I'm going to call peopleclient.getAllAsync, passing in a new getAllPeople request. Remember, there's nothing in that class, but we do need to pass some kind of message. And then if that comes back, we're going to also check the time and how long it took and do all that as well. And tell us how long it took. So what do you think? You think it's going to take less time or more time? Well, just for reference, let's go and run our API again. And that took 2.8 seconds. Second time it takes should be less than 2. Now here's gRPC. Whoa, 470 milliseconds. Did you see that? Now that was the first time. What about the second time? 306 milliseconds. Okay, so there's the case right there. It took less than half the time to get the same data using gRPC than it did using the standard API controller. Now let's add some more functionality to our service. Because if you notice in the controller, we not only have a getAll, but we have a getById. So let's add that to our service. Go back to People Proto. And what I've done here is I've added this message, getPersonById request, that takes an ID int. And then I've added another remote procedure called getPersonById that takes a getPersonById request, which contains that ID, and returns a person. Now that we've got that defined, we can modify the people service. Or actually, all we have to do is add a method to the people service. And the reason this is not understanding what that is because I have to build that, regenerate that code. And there it is. Now it understands. So we're calling getPersonById, passing in the getPersonById request. And it looks very, very similar to what we were doing in the controller, right? Because it's using the same data, personsmanager.people. Now let's modify indexRazor to handle this. So we've added this button here, getRandomPerson. So what it's going to do is pick a random number between 1 and 5,000 and then get that person by ID using gRPC. And it'll show the results right there in person results. And here is the code. Now, I don't know if you've used the randomizer before in .NET, but it's pretty cool. This is a little trick that I figured out. I don't know if I learned it somewhere or I figured it out. The random object takes a seed, which is an integer, and that in and of itself can be pseudo-random, but that helps to create more random numbers. So every object has a getHashCode method. So all I'm doing is creating a new object, getting the hash code that returns an integer, which is going to be fairly unique. I'll use that to seed the randomizer, and then I'm going to call rand.next between 1 and 5,000. So give me a random number between 1 and 5,000. Then I'm creating a new getPersonById request, passing in that random ID. Then I'm calling peopleclient getPersonById async, and I'm awaiting that, passing in the request. And if the person is not null, then I'm going to show the ID, the first name, and the last name. Let's try it now. There it is. 4005. And I can just keep clicking on this, getting random people. And of course, this still works. And our old sluggish API also still works. Now, this wasn't enough. I wanted to see how this performed when published to an Azure web service. So I did that. And here it is, Blazor gRPC demo server.azurewebsites.net. Now, don't worry, I took it down. I don't want to incur a lot of charges, but let's just try this from scratch. Okay, well, first of all, the API performs better when it's in Azure than when it does on my machine. That's interesting. 975 the first time, 862, 793. All right, what's gRPC? 391, 277, 278. So it's still performing more than twice as fast. And of course, getting random person works just fine. So this is by no means an extended tutorial on gRPC, but what I hope it does do is motivate you to learn gRPC and use it where it makes sense. Back to you in the studio, Carl. You know, gRPC performance is great, but there are many unanswered questions. Can I just turn my existing API controllers into gRPC services using some kind of wizard? Do I really have to give up my existing classes? And what about partial classes? It all seems so messy. Well, you're right about that last bit. Perhaps we'll continue to see great tooling coming out of Microsoft and the .NET community. Time will tell. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze a trail.